Okay, hello, Math 20-1. Okay, so we're just getting into the trigonometry unit. This will be lesson 1. Here are the things that I'm going to want you guys to be able to do by the time we're done this. So, sketch an angle in standard position, give the measure of the angle, determine the reference angle for an angle in standard position, draw an angle in standard position, given a point, just any point, on the terminal arm of an angle. Alright. Okay, so a bit of terminology here first, so you have to make sure we know what we're talking about. For a point on the coordinate plane, when an angle theta is between 0 and 360 degrees, the angle is measured counterclockwise. So just make sure you guys know that. So if we're talking about any angle in standard position, we're talking about the angle counterclockwise, so going that direction, right? From the positive x-axis, that just means the x-axis on this side, right? That's the positive part of the x-axis. And we call that the initial arm. So these are going to be called arms, the things coming off of these, just like arms. And the initial arm is just where the angle is coming from. It's the initial place where it is, right? So we said, so if it's being measured from the initial arm like that, it's said to be in standard position. Okay, the line joining the point and the origin is called the terminal arm. So what they mean by that is, here's my point, right? Just any point, it could be anything. Here's my origin right at the center, right? 0, 0. So that arm that's joining those 2 points is called the terminal arm. And the word terminal, if you need a way to remember this, the word terminal means end, right? It means the end of something. So just like at the airport, the terminal is like the end, the last part of the airport before you get on the plane. It's the end. So if you have an angle, that's going to be the end of my angle is at that arm. The point P is the terminal point, we call it. So point P there, that's where the angle ends. We call that the terminal point. Okay. Trigonometry key terms here. I also put this on my blog too, so you guys can make sure you know what, when these things come up in the test or in any question, you know what I'm talking about. The Cartesian plane, that's this. So as soon as I say the Cartesian plane, I just mean, one of these grids that you guys have seen probably a million times. It has 4 quadrants. You guys have dealt with these quadrants before. And the only thing to remember is that it starts at quadrant 1 right here, right? This quadrant over here. And then goes counterclockwise. It counts this way. So counterclockwise, that might be counter to what you might think. Yeah. So the initial arm, again, that's going to be the arm where you start on the positive part of the x-axis, and the terminal arm, that would be that arm coming out of there, and reference angle. So reference angle is going to be, let's say I had like an angle like that. The reference angle is always the angle back down to the x-axis. So this would be my reference angle in that case. But if I had like an arm that was coming off in this direction, this would be my reference angle. It's just an angle always back down to the x-axis. Okay, moving on. Okay, so we're going to go through just a couple examples here. It says the point 4, 7. So this would be 4, and this would actually be 7 in that point there, right? Some point right there. Is on the terminal arm of an angle in standard position. So we're looking at it from the positive x-axis. That's what makes it standard position. It says determine the distance r, so the hypotenuse of a triangle, from the origin to P. So from here to there. Okay, so we know though if x is 4, that means that the bottom of my triangle, or my adjacent side, that's going to be 4, right? So that length right there is going to be 4, because I have to go 4 over. This length straight up and down, that's going to be 7, right? Because that's my y value. So I already know, I said 7 and I wrote y. 7. Okay, we already know 2 sides of this triangle, right? We should be able to figure this out with simple trigonometry. So a squared plus b squared is equal to c squared. And r in this case would be our c squared. That's the hypotenuse. So if we just fill that in, we've got 4 squared plus 7 squared is equal to r squared. Okay, so we've got, if you actually do that, 16 plus 49, so 65 is equal to r squared. So then, let's say, therefore, those like dot dot dot, r is going to be equal to the square root of 65. So I know that this top part here is going to be square root of 65. And we like to keep it as a square root if we can in this case, so we're going to be doing this for trigonometry for the rest of the unit. Decimals aren't really that great for us because then we kind of lose accuracy, so we're going to keep it as a square root. Okay, so now it says determine the primary trigonometric ratios of theta. All that means, actually let's do a little review, is trigonometric ratios. Hopefully you guys remember seeing something called SOHCAHTOA. If you haven't, that's alright. So, kind of written like this. SOHCAHTOA. It's saying really, so this is sine, this is cosine, and this is tan. That's the identity of sine. It's going to be opposite over hypotenuse. Cosine would be adjacent over hypotenuse. Tan would be opposite over adjacent. So if I go down, it says determine the primary trigonometric ratios. It wants sine, cos, and tan, and then just put the opposite over the hypotenuse. For sine, cos would be adjacent over hypotenuse. I'm just going to pause it and fill that all in. Okay, so this is all I really want. So sine theta would be 7 over square root of 65. That's the primary trigonometric ratio for sine. Cosine theta would be 4, because that's my adjacent, over the hypotenuse of 65. I'm just looking back at SOHCAHTOA, right? So cos was adjacent over hypotenuse. So adjacent was 4. Hypotenuse was square root 65. Tan, opposite over adjacent, so 7 over 4. Last one says determine the measure of theta, so the angle, to the nearest degree. Okay, so now if you don't remember how to find the angle on your calculator, I'll show you here in a minute, but this is the way you'd write it down. So just starting off with what we had there for the sine theta is equal to 7 over square root 55. If I want to solve for the angle there, I just write it a little bit different. I'd write it as sine -1. And then in brackets, now it's going to be 7 over square root 65. And that's equal to theta. Try a little bit better, theta. So you just have to punch it in like that into your calculator. And just to make sure that you know what I'm talking about, I'll show you how to punch that into your calculator. So if you go trig, and then you can see that you've got sine, cosine, all that kind of stuff, but then you've also got sine -1. That's the one we want now. So click on that one. And then you just literally put in, what was it, 7 over square root 7 divided by square root 65. Okay, so the angle here to the nearest degree is going to be 60 degrees. And if, let's say, I did this, what would you expect that I would get? Well, it's actually going to be the exact same thing. These ratios, if you end up finding out the angle of this, you end up getting the same angle no matter what trig ratio you're using. So these are all equal to 60. Okay, moving on. Okay, so for this one, I'm going to help you a little bit, but then I'd like you guys to give it a try on your own. So this one says the angle theta is in standard position in quadrant 1. Cosine theta is equal to 5 over 13. So this is giving us info, right? So if we have our SOHCAHTOA, then we have a little clue here since it's cosine theta is equal to 5 over 13. If I look at the SOHCAH part of it, so this part of it, I can see that cosine is adjacent over hypotenuse. So right here, it's told us the adjacent, and it's told us the hypotenuse of our triangle. So the only thing we're missing from this triangle is the opposite side. So if you ended up making this into a triangle, we've got the hypotenuse, we've got the adjacent, we're just missing that. So I'm going to fill in what we have so we can solve for this. So cosine theta adjacent, so 5 was the adjacent side. Hypotenuse was 13, so I'm going to just put 13 there. And now it says, what are sine theta and tan theta? Well, both sine and tan require the opposite side. If I look up here, sine, yeah, that needs opposite, and tan, yeah, that needs opposite too. So pretty much what it's saying is find the opposite side and then just plug back in the trig ratio. So I'd like you guys to go ahead and see if you can do that. Okay, let's see if we can figure this out. So if I go a squared plus b, oh, that's a terrible b. B squared is equal to c squared. Now we know c squared, right? That's, or c. That's going to be the 13, right? So I'm just going to fill in what I know here. I'm going to say, so 5 squared, that's that part down there, plus, we don't know b squared yet, is equal to 13 squared. So I can say b squared is equal to, actually I'm just going to go back a step and maybe put the numbers in so we can see what I'm doing here. Okay, so 5 squared, that's 25. I'll leave that as b squared. Is equal to 13 squared is 169. Okay, so what you gotta do, remember, is just subtract 25 from both sides. So we've got b squared is equal to 144. So then square root of that, b is equal to, is that 12? Yeah. So b is equal to 12. Okay, so our y value here now, so up and down to the opposite side, that's going to be 12. So now, that's the hard part. That's really everything that's difficult about this, because now it just wants to know what sine theta and tan theta are. Well, sine theta, I'll write this over here. Sine theta, according to SOHCAHTOA, is opposite over hypotenuse, so that's just 12 over 13. Tan theta is opposite over adjacent, so that's just going to be 12 over 5. Okay, so just like that. Okay, so I'm going to let you guys go ahead and try this one on your own. Okay, there's your answers for that one. Okay, so I'm going to end that video there, and I guess I'll see you guys in the next video.